Welcome back. You just saw the video on the river Vjosa, one of the last remaining natural rivers in Europe. In the following lecture, we go into how rivers develop over time and how they behave as natural systems. For this, we refer to the scientific disciplines of hydrology and hydraulics, morphology and ecology. We do so in order to better understand a river like the Vjosa and more in general to understand how landscapes shape rivers and rivers shape landscapes. As this MOOC is about Room for the River, our focus is obviously on the spatial dimension, but that dimension in turn relies on the fact that rivers are systems governed by so many feedbacks that they seem to have a will of their own, almost like a person. So we can ask, what would the river itself actually want? In the next lecture, we let humans enter the stage, and illustrated on our Dutch Rhine River, we show how rivers respond to human interventions. But first, their own behavior. Here is the outline of the two lectures. We introduce rivers as connecting catchments to coasts, transporting water and sediment from the mountains to the sea. This results in distinct river stretches and very different patterns, as a consequence of what rivers achieve in very different settings. Different settings in physiography, mountains or plains, and different in climate, tropical monsoon to arid. Following a chain of causes and effects, we then especially focus on alluvial river stretches. That is, those stretches where rivers build and shape the landscape by depositing sediments. How different the results of this may be will be illustrated by looking at the morphological development of two completely different rivers in different settings. Developments that result from different balances between river discharge, regime and sediment, and resulting in different landscapes supporting different ecosystems. In the second lecture, we focus on the Dutch part of Rhine River, the river that was the object of the Dutch Room for the River program. The reason for this focus is twofold. It's a perfect example of human interference and of how the river responds. We show how this part of the Rhine River developed since the last ice age and how humans disturbed the processes and balances. Implicitly, we thus explain how this led to the paradigm shift towards Room for the River. In essence, rivers are simply the result of rainfall falling in a catchment, or snowmelt, and its flowing towards the sea, subject to the laws of gravity. Sometimes after first flowing below surface as groundwater. In that case, we can define a distinct source of a river. Because of differences in relief and geology, the kind of rock, smaller rivers flow together and add up to larger rivers. Rivers joining are called tributaries, and when a river splits up, which it sometimes does in a delta, we call these branches or distributaries. Some catchments, like the one of the Mississippi in the picture on the right-hand side, are very big. In this case, because it drains an area extending from the Rocky Mountains to the Appalachian Mountains, and from the Canadian border to the Gulf of Mexico, where we see a distinct delta with many river branches, and the Birdfoot Delta, as this particular one is called because of its shape. This delta is an indicator of sediment being moved, which brings us to the next sheet. Here we see the longitudinal profile of a river running from the mountains on the right towards the sea on the left. Along this profile, we can distinguish three reaches or stretches, an upper reach in which erosion predominates, a middle reach, and a lower reach where sediment is being deposited. This gives us a clue about what rivers do and achieve, namely denudation, that is, lowering mountains. And at the other end, the building of land by aggradation in alluvial fens, alluvial plains, and deltas. This development, which is very, very slow, changes a river's character during its lifetime, as illustrated from top to bottom. We're talking geological timescales, as slow as forming mountains. The lower reach is often addressed as the alluvial reach, although such alluvial reaches can be found in mountain areas too. In these alluvial reaches, processes are much faster. In this course, we shall focus on such alluvial rivers. because here rivers truly shape landscapes. And also here, humans compete with the river for space, the second part of this presentation. Before we move on, I would like to draw your attention to the typical cross-sections in the photographs, usually V-shaped in the upper reach and plain in the lower reach, hence the terms alluvial plain and floodplain. And for those who are keen on terminology, floodplains actively contribute to discharging floods. Alluvial plains may be fossil. Now, that was physiography, relief and kind of rock, partly explaining the development of a river. But the other key determinant is, of course, climate. For this determines the discharge regime. Here, just as an example, 3 large rivers in different climates. And what we see is the mean monthly discharge. The Mississippi is a typical example of a river in temperate climate, always flowing. The Ganges and Brahmaputra are subject to monsoon, dry and wet seasons, with the Ganges falling almost dry almost every year. Left on this sheet, you can see what the different physiographic setting and discharge regime can mean for the different shapes that alluvial rivers can have. In lowland stretches where sedimentation exceeds erosion, they will usually start braiding, especially when the sediment load is much too large to carry, so that the river is choked. Then the usually multiple channels simply move around the obstruction by changing course. When the slope of the river is less and sediments are finer, rivers will meander, while they erode their outer bends where stream flow is fast and deposit the sediment again in the inner bends where stream flow is slow. Thus, the bends move through the alluvial plain by means of lateral erosion, as shown at the bottom right. By doing so, they rejuvenate the floodplains. For a thorough understanding of the differences, this sheet also shows a balance. For rivers appear to maintain a balance between the water flow, the stream power, a function of discharge and steepness, and the amount and grain size of the sediment they carry, boulders, gravel, sand or finer. And any deviation results in either erosion or deposition of sediment, and in different types of rivers. Let us have a closer look at 2 large rivers with different behavior: the Brahmaputra River in Bangladesh and the Mississippi River in the United States. The Brahmaputra is a braiding river, as shown on the satellite image bottom left. You see the braided pattern of the multiple channels and the clear difference between the dark colored water and the yellowish fresh sediment deposits. And as the picture above shows, it carries coarse boulders and has little discharge in the dry season. The Mississippi River is a meandering river, as the reconstruction of its morphological history by Fisk from 1944 in the hand-drawn map bottom right clearly shows. The picture illustrates that it usually carries water and that the meanders are prone to being cut off. This changing course of a river can even better be illustrated by not only looking at pictures, but by watching how they change course over the years and how they use the space around them to create a new landscape. A sequence of satellite pictures of the braiding Brahmaputra River shows how dynamic a river may be. For your reference, we marked some farmlands in the floodplain in red. And we also added a scale bar at the bottom left, measuring 10 kilometers, 6 miles. So you can imagine how huge this Brahmaputra River is. Even the agricultural islands indicated in red are over 10 kilometers long. In the second part of this presentation, we will focus on the Rhine River in the Netherlands, which we consider big. But although it qualifies as a big river in Europe, it is about 10 times smaller than the Brahmaputra River. Now watch what happens in 20 years. And if it goes too fast for you, don't worry, just repeat the video and imagine what is happening on the ground level. So, Did you see how the channels eroded the existing land and created new? These are the so-called chars in Bangladesh, islands in the river that are temporarily used for agriculture in the dry season, but flooded and changed during each wet season. By the way, these videos are made using the Google Earth engine, which is available for free on the internet, just in case some of you might want to try to create a video of your own river of choice for this week's assignment. So far, we looked at the hydrodynamics and morphodynamics. But what is the ecological relevance of all this? After all, an important motivation for the Room for the River program was the observed loss of biodiversity. Now, let us look at rivers from an ecological point of view. For rivers support diverse ecosystems. On the left of this sheet, we show some river ecosystem concepts you may come across. They concern the whole river. On the right-hand side, two typical cross-sections are shown, depicting the diversity of habitats along a small river on the top and along a large river like the Mississippi at the bottom. As for the ecosystem concepts, I would first like to draw your attention to the second one, the river continuum concept. This represents the fact that rivers provide a longitudinal gradient of gradually changing environments from upstream to downstream, and at the same time along a gradient from deep channel, permanent water, to never flooded uplands along the banks. That is a continuum of many different environments, and thus providing habitats for different plant and animal species. The fish zones on its left are just a specification of this concept for fish. The second key concept is the flood pulse concept. This represents the key role periodical flooding plays in bringing sediments, nutrients, etc. onto the floodplains, key for the development of typical floodplain vegetation, and don't forget seeds, but also temporarily providing shallow water as spawning ground for fish. Here too, the productivity model on its right-hand side is just a specification of this concept. So, with the river continuum concept describing the intricate pattern of environments, and the flood pulse concept describing the key processes which determine the differences between these environments, we end up with an intricate and very diverse mosaic of ecosystems. The cross-sections on the right-hand side of the sheet reflect this. But these ecosystems are all related to each other, strongly depend on each other, and together constitute an ecosystem at even larger scale. We could say rivers support a diversity of ecosystems, connect these ecosystems, and are ecosystems, ranging from the catchment to the coast. And obviously, each river is different and therefore unique. So please imagine what your own rivers look like from this point of view. To finish this first part, let me stress that this introduction is primarily aiming to draw your attention to the fact that in river systems everything is connected. Firstly, because hydrology, morphology and ecology are connected, but also because of spatial dependencies in rivers, between upstream and downstream, between channel and floodplain and alluvial plain. It means that no intervention in a river can be done without the river responding, sooner or later, nearby or at distance. The consequences of human interventions are the subject of the next part.